Extraterrestrial life, whether simple bacteria or complex organisms, has long been hypothesized to exist in the universe, and the testing of these hypotheses is called exobiology. Physicists such as Stephen Hawking believe it would be improbable for life not to exist somewhere other than Earth, due to its vast size and constant physical laws, despite no direct evidence. This idea is summed up in both the mediocrity and Copernican principles, which both simply state that the Earth isn't special and the universe doesn't revolve around us, hence the evolution of intelligent life is likely to or has happened elsewhere. In 1961, astronomer Frank Drake came up with an equation to estimate how many detectable civilizations might exist in our galaxy, the Milky Way. In this equation, n is the number of civilizations in our galaxy in which radio communication may be possible, r is the average rate of star formation, fp is the percentage chance of stars with planets, and E is the average number of habitable planets per solar system. Fl is the percentage chance a habitable planet develops life. Fi is the percentage chance that this life then goes on to develop intelligence. Fc is the percentage chance that life can then communicate detectable signs of its existence. And L is the length of time that the civilization will send signals into space. Values range from 2 to 280 million. Mainly due to the fact that the last four variables in the equation aren't known. If we were to look at the equation closer, for R, the average rate of star formation, NASA's latest calculations indicate the current rate of star formation in our galaxy to be around 7 per year. For FP, the number of stars that have planets, analysis of microlensing surveys suggests that stars are orbited by planets as a rule, hence each star in the Milky Way is bounded to one or more planets. For NE, the number of planets to support life, this is estimated to be around 40 billion. For FL, the number will actually go on to develop life. This process is called abiogenesis and seems highly probable, as geological evidence from Earth suggests that life here began around the same time as appropriate conditions arose. Hence, if the conditions are correct, abiogenesis is relatively common. FI, the number that will develop life that's intelligent, is controversial, seen as biologists such as Ernest Mayr point out that whilst billions of species have existed on Earth, only humans have become intelligent. However, as life generally becomes increasingly complex, this value could approach 1. For FC, the number of civilizations that will develop technology to communicate, there is much speculation on this part, as extraterrestrial civilizations may exist, but choose not to communicate to us. For L, the length of time in which the civilizations will release signals, science historian Michael Shermer estimates this value to be around 420 years. The Fermi paradox is put forward by physicist Enrico Fermi and is the apparent contradiction between high estimates of the probability of the existence of extraterrestrial civilization and the lack of contact or evidence with such civilizations. The main points of the argument are that the Sun is a typical star. There are billions of stars in the galaxy that are billions of years older than the Sun. There is a high probability that some of these stars will have Earth-like planets, and assuming the Earth is typical, some may develop intelligent life and interstellar travel. So according to this line of thinking, Earth should have been visited by aliens. However, Fermi saw no convincing evidence or signs of intelligent life in the observable universe. There have been many solutions to the Fermi paradox, some of which seem plausible and others more far-fetched. For example, the phase transition hypothesis states that Earth is still evolving and changing, thus the conditions to support advanced intelligence have only recently occurred. According to this theory, supercataclysmic events called gamma-ray bursts account for this by sterilizing large amounts of the galaxy. A completely different theory is the simulation hypothesis. This implies we haven't been visited or interacted with extraterrestrial life because we're living inside a computer simulation, and this simulation isn't generating any companions for us. This Matrix-esque proposition is bizarre, but explains the Fermi paradox. There are numerous techniques used in the search for extraterrestrial intelligence, or SETI. As stated, electromagnetic radiation is monitored for signs of transmissions from civilizations. Some of the most well-known projects conducted by Harvard University and the SETI Institute. Radio telescopes are used to investigate the cosmos for Earth-like planets, using large radio antennas, and there is also the possibility of searching using the microwave spectrum. The first modern SETI experiment was done with a 26-meter-long radio telescope. Soviet scientists took a strong interest in SETI during the 1960s and performed a number of searches using omnidirectional antennas. The mission of NASA's Kepler Space Telescope, when launched in 2009, was to identify and characterize Earth-sized planets and the habitable zones of nearby stars. It orbits the Sun every 371 days, while sensors monitor the brightness of more than 150,000 stars simultaneously, looking for drops in intensity which could indicate orbiting planets. As of September 2012, Kepler had flagged more than 2,300 planets and shown the advancement of SETI technology. In fact, it is predicted that by 2040, astronomers will have scanned through enough systems to give a good chance of discovering alien-produced electromagnetic signals. Hence, the possibility of discovering alien life may be much closer than you think, provided of course that the simulation hypothesis isn't true.